This lecture can be considered to be linked to chapter 7 in the environmental management book, but also other chapters like 8, 9, and 10, because I'm going to be talking about resilience, exposure, sensitivity, vulnerability in connection to climate change. I have a number of points to take us towards later in this presentation, so please bear with me. I'm going to start out with something which is referred to as the urban environmental transition. There were a group of researchers about 20 years ago that were thinking about the Kuznets curve in economics, and they started talking about an environmental Kuznets curve. And then they started trying to apply this to the concern about environmental problems and the severity of environmental problems and the policy and political response to environmental problems as played out through various places around the world. And this resulted in this diagram, which you see here, which you may come across in other circumstances in the future. This isn't just a question of environment, but it's also about public health, city planning, and so forth. So if we look at the diagram, we see that we have the y-axis where it says increasing severity, and then we have the x-axis where it says increasing wealth, either over time in a particular location, or if we move from one location to another in different countries. The red to sort of brown line is local burdens, the blue one are city to regional burdens, and the green one are global burdens. So we start off in a particular city, because they were interested in cities and urban areas. Then the beginning, most of the environmental problems and most of the public health problems are very local. For example, people have indoor stoves for cooking. And so it becomes very much of a local air pollution problem. The air pollution outside in the city itself is so-so, but the biggest problem is indoors in this example which they have here. As individuals in the city and as the city itself becomes more wealthy, then we are able to replace wood-burning stoves indoors or charcoal stoves or whatever, and maybe there are some electricity, maybe there's some gas that's being used. So the indoor problem is reduced, and instead in the city itself or in the region, we have outdoor air pollution problems. And then at some point we have either removed the polluting facilities further away from the city or the region, and we have these long electricity transmission lines into the city, or we have tough environmental legislation or whatever it is. And so the ambient air pollution in the city and the surrounding area is improving again. And then finally, we reach the global level where the air quality in and around the city is quite good, maybe even as good as it was before industrialization began. But the activities of people and organizations in the city are causing a global problem, greenhouse gas emissions. We could also use this diagram to look at a city someplace in the world today. In a country where they are relatively poor, they would tend to be on the left part of the x-axis, whereas we who live in Malmö tend to be on the right part of the x-axis. And this was an example with air pollution. We could think about water quality. We could think about a variety of different matters which are in the sort of public health and also the health of the natural environment, or the health of not the people, but other organisms in and around a city. We can see that this diagram is, well, it's compared to some scientific research, it's new, but compared to others, it's old. And this idea has been further developed in later publications, and others have sort of used this instead. This is sometimes referred to as an environmental Kuznets curve, or it's a combination of several environmental Kuznets curves. And I'm assuming that you have, or you will have, run across Kuznets curves in sort of macroeconomics information courses in the program. I'm just interested in this particular lecture and this particular point in time. Now, we cannot know for sure a future climate. We understand that most weather forecasts for a particular location, we can reasonably rely on them several days into the future. And in a place like where we live, I'm assuming for the moment that most of us are living in or near Skåne, that there are certain periods of time during the year where weather forecasts have a high degree of accuracy, and they can even be fairly accurate as much as a week into the future. Whereas other periods of time of the year, if you follow this and make note of this, you'll see that it's very hard for them to even get a good weather forecast 3 days into the future. It has to do with the macro scale movement of weather systems and fronts, and that it's easier in some places of the world in certain seasons to predict the weather than in others. And then occasionally they get it wrong. But anyway, and of course, in the climate, there's a lot of weather, and where weather ends and where climate starts are sort of a bit fuzzy. We usually don't talk about the climate during a particular year. We often talk about the weather in a particular year. If we're talking about 10 years, we might be talking about weather, but we're more likely going to use the word climate for a 10-year period of perspective. So it's a bit fuzzy where weather and climate go from one to the other. And we have a number of emission scenarios that various researchers work with, and we have the IPCC, and we have what is referred to as climate sensitivity built into various models about how sensitive the climate will be to increased levels of greenhouse gases in the atmosphere. And all of this, of course, leads to a fair amount of uncertainty. And then that uncertainty could also be linked to that previous slide. We have a certain amount of uncertainty at a city level. What should we do, even though we are just one of many cities around the world, and what we do in one city doesn't make all that much difference? I see that there are some comments going back to the previous slide. It's also the perception of burdens seem to be produced by the country itself. Yes, that's correct. But the amount of policy activity, the amount of investments that are going into various environmental problems is going to vary depending upon what is considered the severity of the problem and to what extent we can actually do something about it. If we have people that are dying by the dozen because of local or city level ambient air pollution problems and indoor air quality, then politicians may feel compelled to act, to do something for political reasons, but also because they have certain power, certain authority, and they are compelled to act, to do something to save lives. And then as we move to the right, things start to feel a bit more abstract until, of course, changes in the atmospheric composition in the troposphere start to lead to change in global climate, which start to lead to changes in regional weather, which then maybe suddenly compel us to act there. Yes, and of course, we have in some cities around the world, we have cities which are a combination of this. There are some rapidly industrializing countries. Some of them might be in Africa, say, but we also have countries that have industrialized, or at least partially industrialized in the past, say Brazil, where we have in the same city, we have all of these burdens taking place at the same time. Whereas in a city like Malmö, we are on the right half in varying degrees. Another diagram. Here we look at changes in temperature. This could be globally, or it could be a particular location. Let's assume for a moment it's a particular location. You could think Malmö if you want to, or wherever you are at this moment here. We have the probability of occurrence of any given day, the temperatures. And we have cold temperatures, average temperatures, and hot temperatures. And right above average in the x-axis, we have a little mark, and that would be the yearly average temperature for a particular location, say Malmö. If we ignore the shifting arrow and the bell curve on the right, the one on the left, where the center of that is directly above that little mark where it says average, we have some days in a particular location that we deem as cold, and we have some days that are hot, and then we have most everything spread around this average, this bell curve. This is a simplification. And what happens if there is a change in the global climate, which leads to a change in the local climate or the regional climate? One might assume that there's increase in mean, that the whole bell curve gets shifted to the right. So we suddenly have, well, suddenly, during a number of decades, we have this shift, and we essentially no longer have cold weather, or what we once thought of as cold weather. We still have some days that we suddenly start to think of as being cold, but once upon a time, those were not considered cold days. They were just mildly cool days, maybe. And we have a lot more weather that was considered to be hot in the past, and suddenly we have temperatures that we have never experienced or rarely experienced before, and we're experiencing this a lot more. So we have 365 days in the x-axis, or 366 occasionally, but we'll simplify that with 365. And that each day, on average, if we take 30 or 50 years, that we plot this and we get this bell diagram, and then in the future, this has been shifted to the right. But we could also have a change in climate in a particular location, which isn't necessarily caused by humans, where we have an increase in variance. We still have a bell curve, but this is stretched out a lot more. A location, because of non-human activities leading to climate change, there are other reasons for the climate changing, that we have much more cold weather and much more hot weather, but the average is the same. We could even view this diagram, this B diagram here, is that if we have a city like Malmö, that it might be the bell curve, which has the sort of higher top, the less variation, but more days that are not cold or not hot. And then we could have a city which has the same average temperature, but might be in the interior of Russia to the east. We're moving from a maritime climate to a continental climate. That their average temperature is the same on a yearly basis, but their winters are much colder than our winters, and their summers are much hotter. But a lot of this variation disappears if we just consider the average temperature as what we're interested in. Then we could have a situation where there's an increase in mean and an increase in variance, as we see in this diagram. The bell diagram is pushed down and pushed to the right. We still have cold weather, not in the way that in this diagram we really don't have what we have considered cold weather anymore. We still have cold weather, but it's very rare and it's not very long, isolated events. But now we have a tremendous amount more of what we once referred to as hot weather. This is also almost starting to become part of the new normal. And then much more record hot weather is occurring. Now, the question we can ask ourselves when it comes to human-induced climate change is, what is it that's going to occur at any particular location? Is it this sort of yellow framed diagram? And I think many of us go around in our everyday life and think that, yes, that's what's going to happen. Or is it this that's going to happen? And I think many of us in our everyday life don't go around and think that there's as likely a possibility of the red framed diagram to occur as the yellow or orange framed diagram. Now, in a literature which is not part of this course, but I feel like I'm compelled to say something about this in 2 slides here. I think my explanation is good enough that you don't need to read about that in anything. But the author of this other kind of book talks about the cascade of uncertainty. And we need to consider this with regard to that urban environmental transition or uncertainty and those diagrams that you just saw there. And unfortunately, it could be that the picture of me is covering up some of the text. I tried to make sure that the upper right-hand corner didn't have all that much text. Sorry. Or maybe it'll just be in the recording. Now, climate models that exist, these are, of course, simplifications. We have researchers that have developed and tested and further developed these. And as most climate researchers suggest that do climate modeling, that you should not just rely on one model, that we should have a series of different models that have been developed in different meteorological institutes, different universities or networks of universities around the world, and then to see the results of a series of models to see the greater likelihood or less likelihood for the future. Because there could be built-in problems that we're not aware of in some of the models, certain assumptions. These climate models are usually referred to as a GCM, which is not a global climate model, as you may think, but it is referred to as a global circulation model, because it isn't just the air, it's the oceans that are also included in these models and how currents change. So the abbreviation GCM is a global circulation model. So we take various kinds of emissions and societal change scenarios and we put them into a global circulation model. And the more complicated the models are, the more data points, the more the world is broken up into boxes that are, say, 100 by 100 kilometers in size, as opposed to 1,000 by 1,000 kilometers in size, which the original GCMs were. And the more change in elevation, in the past, maybe the troposphere, the lower atmosphere, was just considered to be one cell, 1,000 by 1,000 kilometers in size. And now we might have a dozen cells going from sea level upwards, not uppåt. I guess I'm thinking in Swedish and translating into English as I'm talking. Isn't that strange? Anyway, and depending upon whether we have some simple kind of GCM that could be installed on a laptop and run it, and the laptop will get very warm and will run and not be able to do anything else for a few hours, or we have whole rooms filled with these supercomputers. And out we get our results. Now we can take these GCMs and we can regionalize them. That is to say, we could run a global circulation model, but then in part of it, say we could take Scandinavia. We could say, okay, here we want to have cells which are just the size of, say, 30 by 30 kilometers in size on the ground, whereas globally they're at 100. Maybe we try to include in this regionalization, we include a bit of topography. And now push the button and run the model to be able to see what regionally we might be able to see as more local kinds of impacts in the future that might occur. And then we can run that. And we can do this many times. And in the best possible kind of scenario for the future, not the scenario of climate change, but the scenario would be that various important actors in society, government authorities, the government itself, ministries, businesses, not necessarily the small businesses, but at least larger businesses could try to take this into account and try to have strategies, try to change their strategies and to carry out mitigation and adaptation. And if the market is working, then we have larger companies that make decisions, which then force smaller companies to make decisions based on the larger companies' decisions, which is what we see occurring all the time. The big guys and girls on the international market make certain decisions, which force medium-sized companies to sort of react to that. It's the dynamics of the market force smaller companies to adapt to the decision made on the part of the larger companies. Now we have a cascade of uncertainty, as the author Wilby, who we're not using here, talks about. And a cascade is this picture, which I'm showing here. I've moved myself on this computer. I don't know if that moves me in the recording. And so we see a cascade of a waterfall. It's not just a waterfall and the water falls straight down to the next level in 10 meters. In this case, we see during maybe 10 meters of fall that the water falls in steps in a cascade from one level to the other. And we have the metaphor, therefore, that's being used here, that in the previous diagram, we have these various steps that can come down to useful information that various actors in society can use to various extent. The problem is, of course, that in this cascade of uncertainty, there's a certain amount of uncertainty in the GCMs. There's a certain amount of uncertainty which we have then when we try to regionalize these. There's a certain amount of uncertainty which takes place when various decision makers read the summary of these kinds of modeling. And these amounts of uncertainty can be inherited downwards, and most of us don't realize what's happening. Because for some reason, psychologically, most people, when they see numbers and they see diagrams and so forth, they have a tendency to accept this as true. As opposed to, like, say, one paragraph of text with an argument. As soon as we put numbers in it, the majority of people seem to think that, oh, well, there must be some sort of certainty behind this because there's a number. Whereas in actual reality, the number is an average where we have an estimate that it's between 11 and 15 something. And so we're forced to put some sort of number. So we say 13 and a half, and everyone thinks, okay, they know it's going to be 13 and a half, where there is an uncertainty that's behind it. And what we then see here is that in the best case, that there's an understanding that the numbers we're getting are actually a sort of a spectrum of potential numbers that we might need to be preparing ourselves for. And we can see then that there's some sort of an assumption that there's something that's linear, but it's actually much more complex there. That there are exponential curves which can be behind some of the models there, and that we don't see that. We humans tend to think of everything as being cause and effect and linear. So some of the uncertainties may be mutually reinforcing. That is to say, one uncertainty may compensate for the other one, and we don't see that, or not. Or one uncertainty may make another uncertainty greater. And by the time we come down to when actual societal decisions are going to be made, many of those decision makers don't see or don't want to see the uncertainty. And the natural scientists have been forced to take a lot of that uncertainty and try to give the decision makers particular numbers that they then can react to, or don't react to, as the case may be. And what do I mean by inaction can be seen as rational? If we have some decision makers who, given in mind that maybe they want to be reelected, given that maybe some of their electorate is not so interested in some of these issues, or at least they seem to be saying they're not, and that there is, of course, an uncertainty, then for those people, it may be seen as being rational to not take all that much action, and they can point to the uncertainty. This is, if we talk about the framing and the discourse of climate change, denying, but also gradualism, this is sort of linked to that climate change, yes, it's going to change, but it's going to be gradual, as opposed to a more catastrophic way of viewing things, that climate's going to change and we're suddenly going to have a tipping point and all the ice in Greenland is going to melt in 100 years. Oh, no. Well, I mean, that's rather unlikely, but gradualism also is not the way we should be viewing things. So for some people, they can justify their lack of action because they understand that there's a certain amount of uncertainty behind this, and they want to wait another decade until there's more certainty. Whereas other decision makers feel forced and compelled for the public good, for society's good, to make some decisions, even though there's uncertainty behind it. And the decisions they might not be necessarily the best, but at least they're moving us away from the worst impacts and are reducing activities, which are then reducing emissions. Now, a question we can ask ourselves for, and I'm sort of alluding to this, is what are we preparing ourselves for? let's suppose that the people that I can see on my screen here, and there are 5 of them, these people, let's suppose that you are all kommunalråd in Malmö. And you have met with people from the City Environmental Authority, Miljöförvaltning, and others, and you have invited in the opposition, because whoever is going to be elected the next time, it may be some of you, and it may be some of the leaders of other political parties. And you want to have some sort of, well, let's have a 10-year plan. It doesn't matter who gets elected. We're going to have to do something about this. We're going to have to look a little more word term. What are we going to prepare for? What are we going to prepare the city of Malmö during the next 10 years for climate change? Are we going to prepare Malmö in a scenario exercise for specific threats, that the sea level is going to rise, and that, say, we're going to have periods of some summers in the future where it's going to be much hotter than it's been now? Is that what we're going to prepare for? Well, based on some sort of risk assessment, what is the likelihood and what is the severity of these specific threats? Let's suppose that we have 2 of them having to do with sea level rise and hotter temperatures during the summer. That would be a way of doing that. Another possibility is that we could have several scenarios, and we could see that there are certain threats which pop up in some of these scenarios, but don't pop in other ones. And since we should be a bit humble to realize that we don't know for sure what's going to happen in the future, that there is some kind of uncertainty in these models, that doesn't mean that we shouldn't do anything, but maybe we should not be just preparing the city for specific threats. Maybe we should be preparing the city for a general preparedness for the future. That isn't to say that we shouldn't build a 2-meter high seawall around parts of the Western Harbor, say, as an example. But maybe we should do things which are less physical infrastructure, but more preparing the residents and the organizations in the city to help themselves become more prepared for whatever kind of climate event might occur during the coming 10 years. We can combine working with specific threats with some sort of general preparedness, because maybe the sea level won't rise as much as the models suggest. Of course, that means that building our wall is helping future generations and doesn't help us as much, but okay, we're doing that. And maybe it won't be as hot during the summers, some summers, and for as long as predicted. But that preparation we're doing for a specific threat helps prepare us for the future when that turns out to be the case. And so we have what is sometimes referred to as a no regrets policy. We do certain things that we will not regret because, okay, it doesn't prepare us for the coming years, but it helps prepare for a next generation, or the younger ones of us living today are a next generation, except you don't think of yourselves as that way. And so the question is, are we going to build up resilience in a particular location, say the city of Malmö, based on something which is very specific? Or do we need to build up a more general resilience on the part of the population and organizations, but also the infrastructure and so forth in the city? Or do we need to do a bit of both? Now, those people in universities that study resilience tend to say that when they look at what cities are doing, that they tend to prepare for specific threats, and they tend not to build up the general resilience of the city as a whole. There's also a tendency on the part of cities around the world to think about resilience in the terms of making things tougher. We build a seawall. We add on extra insulation. We do these kinds of things. And another reason, of course, is that politicians, and I'm being very cynical here, they can point to that during the coming 3 years or 4 years or 5 years, that look, we had the plan, we built the seawall, you are now protected, re-elect us. Whereas some of this more general resilience, it's much harder to point out what you have done. You have, just like we have in public buildings in Malmö University, when we're there, once a term, there's a fire drill or a fire exercise. And that's preparing us for a fire. And we tend to forget that we had one of those a month later. But you can see the fire extinguishers and the fire hoses and so forth, and think that somebody's thinking about us and that we can protect ourselves in case there's a fire. It's a somewhat similar kind of idea here, that depending upon the way all of this is framed, we might be thinking about resilience in terms of making things tougher, like a seawall, or it might be that we could be making ourselves more nimble, more alive in our feet, to be able to move ourselves around and prepare ourselves and deal with on the ground the event which occurs, which we hadn't necessarily planned for. And now I'm going to use two metaphors here. Being tougher is that we create a monolithic wall, and that of course will protect us very well from a specific threat, but it will not help us at all with regard to some other kind of threat. The other metaphor here, being more nimble, would be, say, a boxer. We also have, which I've written here in italic, that maybe the way we make decisions about climate issues needs to change. Maybe that's a way to make us more resilient. That's at a such much more deeper level. Maybe we need to change the way the city government is organized. We're still democratically elected, there are still Kommunalråd, but maybe certain things that Miljöförvaltning have been taken care of, maybe somebody else should take care of that, and vice versa, to better prepare us for the future. That's not really something that politicians seem to be talking about. How to reorganize the various sort of authorities and so forth within the city to better prepare the city for climate change. No, we don't talk about that. We have inherited these organizations from the past when climate wasn't changing. Maybe we need to redesign them for a future climate. Oh, really? A university person said that? No, I've never thought about that. So here we have, it's the only example I could find of somebody designing a building. If we ignore the large window in the wall there, we could think about that you could have a wall, you could build a house there, but in the event during the coming years that there's a high tide and the sea is a little higher, we're protecting our building from one side. Again, that window there, we don't want to think about that. Imagine it's just covering up everything. But if we're going to have, going from the level of an individual or maybe a particular building, an apartment complex with 20 or 50 or 100 apartments in it, we have these various kinds of walls. And of course, again, this is preparing us for a series of very specific events and is making the city much more resilient. They're very expensive. They also change probably the property values of the apartments whose view of the ocean is now obscured by the wall. They used to cost 5 million crowns. Now, who wants to live there with a gigantic wall beside it? Anyway, a minor matter, perhaps, unless it's your apartment that's whose view of the sea is obscured. But this isn't preparing us for other events. Now, I like to think of myself as not being a particularly violent person, but I think with boxing, I mean, we're deliberately trying to hurt somebody, and that's considered a sport. If you're into boxing, sorry, but I think that boxing is a really good metaphor here because it involves being tough, but it also involves that in the event that you're being threatened, that you are moving yourself out of harm's way, and you're ready then to be able to then hit that harm but with your right or left fist again. This means that the boxer has a resilience that these walls don't have. The boxer is better prepared for a variety of different threats that are coming at different times and from different directions. And the boxer can run around and think that, okay, I can take one punch to avoid another punch in a way that a seawall can't do. You all probably think that I enjoy boxing. No, again, I don't. But I think this seems to be a way to compare how resilience could be thought of in a city. We're still being tough because these people that are hitting each other are really getting hurt. Often they can be knocked unconscious and they're getting points and money maybe, or medals, who knows. and they are prepared for a variety of different possible attacks, whereas the wall is only preparing us for a particular kind of threat. So when you think about municipalities and, shall we say, climate governance, the question is, how is the city trying to make the organizations, its own organization, the infrastructure in the city, the inhabitants of the city, and so forth, more resilient to coming climate change? Is it the monolithic wall idea, or is it the boxer idea? And what is the city doing? And most researchers who have looked into this seem to suggest that most cities have chosen the monolithic wall for a variety of reasons, and not the boxer mentality. This is an ethical question. If we're going to spend money in terms of adaptation to climate change, where should we spend the most amount of money, and why should we spend that? Now, in all likelihood, poor people in the so-called global south, and that doesn't necessarily mean that they're in the southern hemisphere, that is to say, poorer countries, that people there are more likely to be afflicted by climate change than people in richer places, say like Malmö. If we look at a city in India, which is a country as a whole, which is somewhere between being rich and poor, in a city like Mumbai, as opposed to Malmö, there are some people who are rich and they won't have much of a problem, but the majority of people in Mumbai are probably going to have a problem when climate changes, and they probably already have a problem when climate is changing in a way that we don't have here. So globally, poorer people are probably going to have more problems, and we can understand that generally. They might be making their livelihood from agriculture, and then there are a series of crop failures, and they're destitute, and they become part of the urban poor in a city. Now, if this is the case at a global level, could this be the case in a specific location? Of course it could, and I gave the example of Mumbai, but this isn't something which is talked about all that much. In much of the discourse of climate change, we talk at the global level, and that we feel sorry for those people in poorer countries that are going to sort of, have a rougher time. But what about at the city level, at the more local level, which is why I had that diagram in the very beginning, looking at how we emphasize certain environmental problems at certain times. So all cities around the world are unique, although they can have similarities. And certain people and certain organizations and certain locations and so forth in the city are probably going to be affected by climate change more than others. In the UK, they talk about fuel poverty, that there are poor people, the houses they live in are not designed for cold weather. And so they can't afford to spend more money to heat up their poorly insulated building, and they can't afford to insulate their building. And so they suffer. And then we see year after year in the United Kingdom, in England, we see older people that are found in their house, frozen to death because they had to decide whether they're going to eat something or if they're going to heat. And this is because the UK has terrible housing in most cases. Great British humor, but terrible buildings. So we can see that in a country like the UK, which is seemingly rich, there are structural problems in the building sector for the entire country, in the countryside and locally, which are meaning that certain people are more likely to be affected by terrible weather in the winter. They might also in the future be affected by terrible weather in the summer. So let's look more specifically at resilience, exposure, sensitivity, and vulnerability in urban adaptation to climate change. Let's have a scenario. There are massive cloudbursts. In Swedish, you would say störtregn, I think. And they're lasting for hours, not just 15 minutes. And this is leading to flooding. And this is something which has happened in the past in our given city, let's say city A, B, C, whatever city. But the scenarios, the climate scenarios suggest that this is going to be happening much more often, that we're going to have every year a series of cloudbursts leading to flooding, as opposed to, in the best case in the past, there was maybe just once a year this occurred. So how is the city organized in this hypothetical global south country city? Very likely it's the case that the people that are poor are probably going to be living on slopes where there will be rapid erosion when it rains a lot, because the richer people have not built their houses there, where there's the risk of landslides and so forth. And it also might be likely that they will be living on the floodplain, the places where it's more likely the river is going to rise and wipe away the houses. The rich are less likely to live in those locations. I'm saying likely. There could be exceptions to that. And the poor are more exposed because of their location. And why are they more exposed? Because those are the places that are left over where they can build something to live in a very poor city, in a very poor country. So probably poverty or ethnicity makes them more likely to be exposed to climate change events because of their social economic background. And here we see this argument that's been made in the environmental management book, that we can't just look at nature by itself and society itself. We have to sort of look at these sort of connections here. This means that the rich are less likely to be exposed to climate change effects. Good for them. Once exposed, the poor have fewer resources to recover. And why is that? Well, almost all their belongings have been wiped away in the flood. Maybe they don't have a bank account with a lot of money in it. Maybe they're too poor to have a bank account. That exists in some places. Maybe they didn't have enough money, or the people where they were living, to build some sort of sandbag wall around their houses and maybe protect them from being washed away. The water seeps in, but they don't get washed away. The rich who have been exposed, regardless of where they are, they have more resources to recover. The rich also have more reasons to protect themselves in the same kind of urban environment than where the poor are living. So we see that where we have drastic gaps in the standards of living because of economic disparity, which leads to a variety of problems in general, that when we have climate change, these problems are going to become worse. The differences between the rich and poor are going to become worse. Of course, some rich who have built their houses on the slopes of the floodplain, property might be damaged and they will be less rich as they rebuild someplace else, and they could have been killed and so forth. But this sort of scenario in this model here is a generalization here. This also means that the rich are less sensitive to the same kind of exposure. So there's sort of like a win-win situation. Their houses are not where they're more likely to be exposed, and if they are in a similar place, they're not as sensitive to what happens to them in this sort of extreme event. And could this be that we can see examples of this in the world? Well, I typed on the internet Brazil income gap or something like that, and plump, all kinds of pictures appeared. I believe that the upper right-hand corner is Rio de Janeiro. I don't know where the other ones are located. And we can see this enormous difference here. And we can see in some cases that the slopes have smaller houses and the other areas have much. Yeah. So there is some sort of a point to this. There's some sort of truth from this. Let's think of another kind of example. Hot periods of the year become longer and hotter. The poor, they have poor living conditions. The rich, than the richer ones who are richer, they're more exposed to the heat. They can't afford to have air conditioning, or if they have air conditioning, they can't afford to run it more than 2 or 3 hours a day, and then that's the money they had to spend on electricity. They have fewer opportunities to cool off. Their health may be poorer to begin with, and so a combination of poorer health and exposed to the heat, they are more sensitive. The rich in a similar city, they can afford to rebuild their residence to make it more climate adapted for heat in the future. They can drive to and from work in air-conditioned cars. They can pay much higher energy bills. They can run their air conditioners all the time if they want to. And so the rich are, one, less exposed heat, and the economic changes can be absorbed. They are less sensitive. So it's not just flooding and rain and so forth. is that when we talk about vulnerability, vulnerability is exposure plus sensitivity. Exposure is usually thought of as being a purely natural science kind of thing. The water levels are rising to 10 meters above the normal level of the river. And sensitivity is normally thought of as just being a social economic kind of thing. But as we can see in some of these examples here, that exposure and sensitivity sort of go into each other in some cases. It's hard to draw a line between them. Now, as suggested in your course book, disaster management practice and studies has understood that vulnerability is a combination of exposure and sensitivity. But as they suggest, maybe environmental management and environmental governance maybe has not thought of that yet when it comes to climate change. And so we can say that climate disasters are dramatic, like I've talked about, but also that we can have long-term slow effects that we don't notice much of a change from year to year, but suddenly 10 years later, the urban heat island effect has become much greater. And why didn't we see this before? We were not anticipating. We are suddenly surprised, even though there has been a weak signal that's been occurring all this time, and we didn't see this. When we talk about resilience, it could be that resilience is going to be higher among those with more economic and social resources. That's what the theory tends to say. But there are studies in the literature, academic articles and so forth, which show examples where that resilience isn't always higher among those with more economic and social resources. Or maybe the social resources are very powerful and the economic resources aren't as powerful, and the person is much more resilient as opposed to somebody who has a lot of money but few social contacts. But generally speaking, if you are poorer and less educated, you are probably going to be less resilient, but you might be able to achieve some kind of resilience, particularly if you collaborate with other people in your neighborhood. At least that's the argument. Now, these arguments that I've been making here about resilience, exposure, sensitivity, and vulnerability, this could never happen in a rich city like Malmö. No, this could never happen there. So I have my two examples here, and I used these examples once upon a time in a lecture in Swedish, but I thought it would be fun if there were any foreigners that were taking part in this course in the future, you could learn a word. We have, Old Lady Agda, or Aunt Agda, and we have Aunt Berit. And Aunt Agda, she lives in this house. I don't know where it is. It's someplace in Malmö. I took it off of an internet site showing that a house was for sale. And she has her little house and has a garden in the back. This is a bad example, lots of hard surfaces there. And she has a pond there. And she has enough money so that she can do some limited rebuilding of her home so that it can be better prepared for hot summers in Malmö in the future. And she has an air conditioner in her bedroom and in her living room. So she has two rooms where she can spend the night and the day, and she can be relatively cool. The rest of the house is getting a bit warmer than maybe she'd like, but she's rebuilt the house so she's better prepared. Then we have poor Tant Berit. She lives alone in a small apartment, and all the windows in her apartment face south, which is great in the wintertime, but terrible in the summertime. So there's no movement of air east-west in her apartment. Terrible design of this. Nobody thought about this in the 1960s and 1970s when they built that apartment complex. She rents, and so she can't do much of a change. It's the landlord that has to do something to reduce the amount of solar gain coming through the windows in the south and has to change the ventilation. And she cannot afford to buy and run an air conditioner. So we see Tant Agda is a bit more resilient. She's exposed, but she can reduce her exposure, and she has the resources to change her sensitivity. That is to say that in this example, Tant Agda is not very vulnerable to climate change. Tant Berit, on the other hand, even if she tries to be resilient, she's exposed a bit more than Tant Agda. She's much more sensitive, and therefore she's much more vulnerable. So what we can see here is that socioeconomic differences that exist within a city like Malmö now may be exacerbated or made worse when it comes to climate change. And my question is the city of Malmö emphasizing help to Tant Berit, or is the city of Malmö just doing things in general which help everyone in the city? I think it's not so much Tant Berit that's getting help for a situation that she didn't plan for and has no ability to change all that much. Let's look at some men instead. In those examples, this was a little old lady living by herself who had worked hard for many years and hopes that somebody will help look after her. It's the same thing here. We have Farbror Anders and Farbror Bengt. Farbror Anders, he has one of his adult sons or daughters who lives in Malmö and visits him once a week, even in the summertime when it's hot, to check up on how old dad is doing. He lives in his apartment building, and there are some retirees together with him that go out and walk their dogs, or I don't know what they do, or they play bridge together, what other people who are retired do. I'm being very judgmental and perpetuating a myth. Maybe they play War of Warcraft together. Who knows? They do something together, and that's a sort of a social contact, and maybe they look after each other a little bit. Then we have poor Farbror Bengt. He doesn't have any relatives that live in Malmö, and his adult children don't visit him very often, so he gets visited by them maybe 3 or 4 times a year around Christmas and his birthday and some other things like that. And he's a retiring kind of introverted person. He's not active with the other retirees in the building, and he really doesn't know anybody in his building. So if we think of a prolonged heat spell, it seems like Farbror Anders is in better shape than in Farbror Bengt, because there's going to be somebody who's going to be looking after him and is going to remind him that make sure you have a lot of cold drinks in your refrigerator and so forth. So it's not so much the question of redesigning and having an air conditioner. This is more sort of a social kind of thing. And so we're all thinking about, well, Joe, you have got a little more room there. Aren't you going to include another person? Yeah, exactly. It's a sort of a twist. We have Farbror Mohammed. He has 3 of his sons and daughters living in Malmö. They live in the same neighborhood, and at least one of them visits him once a day, particularly when it's hot, because they love their old dad and they want to make sure that he's okay. And there are a group of people that meet daily at a local cafe, and they sit there and whatever they do there, whatever old people do. And he knows at least a dozen people who lives in his building. So in this sort of scenario and situation here, it seems that Farbror Mohammed is probably the one that has the greater amount of social resilience that can help him manage a long-term heat wave, all other things being equal. All of these elderly gentlemen live in the same building. Farbror Bengt is in really bad shape, and Farbror Anders is somewhere in between. And so we can see that in this case, ethnicity might actually be an advantage for some people to deal with climate change in their small apartment buildings facing south with no east-west wind going through them, like poor Tant Berit. Of course, I'm making sort of extreme cases here to prove a point here. When we're going to have climate change adaptation, we're thinking about intergenerational justice, but maybe we should be thinking about within the same generation justice. Sustainability has sort of made us think about coming generations, but climate change is something, and adaptation and where we should be spending money, the resources the society has for adaptation, maybe there's an ethical component to this. And maybe intragenerational justice is also important, not just intergenerational justice. We have, of course, a much more extreme case with the COVID-19 vaccines, where we make sure that everybody gets a 3rd booster shot, as opposed to sending some of those shots to places where nobody has any vaccination at all. And that's sort of looking at the intragenerational justice, if that's sort of driving it to its head. So I think I'm going to not say anything more. I had a few more slides that you can see yourself as PDF. The PDF file isn't exactly the same as the slides I used today, because there was sort of animation, the appearance of the boxers and so forth. So there may be some things that are missing, but it's essentially the same thing as the PowerPoint presentation. That is the PDF file there. And then we can ask ourselves, are there, if there's environmental governance and climate change adaptation in municipalities, and I've talked about mitigation and adaptation among companies, are there some lessons or parallels that could be learned from what I've talked about here that could sort of be transferred into the company situation? If companies have permitted their employees to work from home during a pandemic, then there might be circumstances with climate change in the future that companies might think that maybe we need to be more flexible about certain things in dealing with our employees so that they can be more productive. As a very small kind of way of thinking about climate change and companies in the future.